excited to walk you guys through the first project that we are going to make using the Picatinny rail and accessory cutters that I helped design with Speed Tiger. So this is the actual cutter that you end up with when you use that form cutting creation process. This is actually the prototype of this cutter. They're the first in existence and I get to play with them, so I'm very excited about that. But when you look at the cutter, you're going to have this thing called tip offset, and there's two ways to treat these cutters, and I'm going to walk you through both of them. You can either make the tip be truly the tip, or you can actually bump that up, and I think it's 0.137. You can actually bump that up to any point along this form cutter. And the reason that is a cool feature to be able to have is that point that you select is going to be where the system calculates the line that this complex shape follows. So I could either move my tip offset up to where we first break off to the 45-degree angle, and then my selection of the geometry being this line would have been perfect. Or I can leave the tip as the tip, still select that geometry, but I'm going to have to come in here and I'm going to have to offset that with a negative 0.137 so that it's cutting at the right place. So yeah, this is a little complex how you have to deal with it, but it gives you options. I personally like this option because I can't always guarantee that I'm going to have a line to select that is a perfect 0.137 below this junction. So instead, I select up here and I just offset it. It's easier for me, but you can do it either way, whatever you like. So now that we've come in and done our roughing of about 1/16 of an inch in, we're going to come back and do a finishing path, and that's going to be with our very different feed and speed preset for our final pass. And of course, we are going to leave no stock. We are letting this cutter define the profile 100%. Very nice. The other thing I want to point out is when I actually calculated out this feed and speed for this cutter, it was about 97 inches per minute. I did some tests on it, which I'll talk about at the end, and you can learn more there. My machine, being a 1 horsepower sort of garage level CNC mill, it's not a huge fan of bits like 3/8 of an inch and higher. This is a 1/2 inch diameter bit, so it definitely isn't super good at optimizing the feeds and speeds for this. And so I actually ended up having to back this down from the optimal feed rate of about 97 at this RPM in order to get a really nice finish that I guarantee will blast out. Now, I'm sure I can push a little further and still get something that blasts out, but this was a good way for me to go and not really test my luck. So play with your feeds and speeds. You can probably get more out of this if you're running a heavier, higher horsepower machine than I am. Next up, we went and ran the exact same thing on the other side. No changes to that. The pick rail. Now, obviously, the main width of the pick rail is going to be highly determined on how you drew it and where you did your paths, because that's just one pass of a bit and another pass of a bit. However, if we get one within spec, the major width here, if the cutter is good, then the smaller width here should also be within spec, because both of those are cut at the same time. So we will be able to check whether the cutter itself is capable of maintaining spec by measuring this out. All right, so I've seen two Picatinny specs. One of them says it's 0.835 plus 0 up to minus 5 thousandths for that major width. And the other one is 0.833 plus or minus 2 thousandths. So there's only a thousandths of difference between those two specs, but let's see where we sit with either of them. All right, so our major width, so we've got 8.8, one notch, that's 25, 38, 32. So we are well within spec for our major diameter with how I cut this out. If we flip it over, I can now take a measurement of the minor width, and we are at 615, which is 2 thousandths of an inch below the max. So I'm 2 thousandths of an inch below the max on my major width, and I'm 2 thousandths of an inch below the max on my minor width. And if you remember back to when we discussed the CAD, I actually bumped my paths in by 1/1000th of an inch on either side from my drawing. So this came out exactly to the 1/1000th of an inch as I would have expected it to. And you might ask yourself, why would I want to be under spec? Well, because I'm going to go Cerakote this, of course, and that's going to add about 1/1000th to 2 thousandths of an inch.